Hello, this is Professor White. Today we will talk about inverse functions and how you find inverses of different functions. And this is a great intro to exponential and logarithmic functions since they are inverses of each other. So this is where we are going with this. All right, let's start with composition of functions. Given f of x and g of x, these are two functions, you are going to go and find f of g of x, f of g of x, or f composite g of x, f composite g of x. Or you can also say the composition of f and g of x. What that means is you start with x and there is this domain and there are a bunch of things in it. But you start with x. Let's call that one element x, the starting set. Then when you take f of g of x, you're going to do this first. In other words, you're going to go and to another set, and there will be g of x in there. Let's say you start with 2, and then the relation was multiplied by 2. So you're going to have 2 here, multiplied by 2, you're going to have 4 here. Now, what you're going to go from g after that, what you're going to do, you're going to apply f to that, not to this, but to that. So you're going to do f of g of x. So this is called composition. So you do f here and you do g here. But you do f first and then you do g next. So this is xgf, xgf. So remember that, okay? All right. Now, how do we do this? Let's look at f composite g of x, which is the same as f of g of x. This is what I do. I go and I actually plug in what g is in here. So you have 5x minus 1. All right? But what do you need to do? You need to do f of that. What does that mean? What does f do? F takes an input, multiplies it by 2, and adds 1. So whatever you put in, so f of whatever, let's say something like that, smiley face, what f is going to do, it's going to take the smiley face, multiply by 2, and add 1. So think of this 5x minus 1 as the smiley face. What is going to happen? 2. Instead of smiley face, I have 5x minus 1. And then what am I supposed to do? 1. And you go and you clean that up a little bit. 2 times 5, that's 10x. 2 times 1, negative 2, plus 1, which is the same as 10x minus 1. All right? So what we did that we took the composition of f and g of x. All right. Now let's go and review something else. We are going to look at one-to-one functions. Sometimes in shorthand they go, okay, one-to-one functions. All right. What a one-to-one function is, each value in the range corresponds with exactly one value in the domain. The starting set is called domain. The ending set is called the range. Each in the range will only correspond to 1 in the domain. Let's say I have 2 and I have 4. I have 3, I have 6. Only 1 goes to 1, 1 goes to 1. Now let's look at, so this is a one-to-one function. Let's think of some like this. You have 2 values and they all go to something. Let's say I go 1 and then this one goes to 1 and then 2, this goes to 1 as well. So let's see. Each value in the range corresponds with exactly one value in the domain. Okay? What does that mean? Is that a one-to-one function or not? So let's look at this. If I were to do this, let's say 1, 1, here's 1, 1, and 2, 1. Okay? What happens to that? 2 goes to 1 and 1 goes to 1, and that's not good because this value does not correspond to that. So what does that mean? So this is not a one-to-one function, because this value in here corresponds to two different things. Okay, well, let's go do this one. Is this a one-to-one function? So let's go look at in here. You have this coming to here, it corresponds to 1. This coming to here, it corresponds to 1. But the problem with this one is that, let's look at that. So let's say I have a 1 and a 1 and a 2. So we have 1 and a 1 and a 2. So these two things are like that. But the problem is, this is not a function. All right? Remember, for it to be a function, it needs to pass the vertical line test. Okay, so what did we learn? For us to have a one-to-one function, this one is not a one-to-one function, and this one is not even a function. So for it to be a one-to-one function, it needs to pass the horizontal line test, and it also needs to pass the vertical line test. Okay? So in other words, when you have pictures or ordered pairs, it needs to pass horizontal line test. That means when you pass a horizontal line, you can only hit 1 point. Here I'm hitting 2. All right? And the vertical line test here, yeah, that is satisfied, but the horizontal line test is failed. How about here? The vertical line test is not satisfied, so it's not even a function. So I don't even proceed to check for the horizontal line test. So for it to be a function, it needs to pass both the vertical line test and the horizontal line test. All right, horizontal and vertical line test. Here's the summary. You do vertical line test to test the function, and horizontal line test to test if that function is one-to-one. So let's look at a couple of this. Some like that, xy. This one fails the vertical line test, not a function. So I stop at that point. How about this? Okay, it does pass the vertical line test, so this is a function. The problem is, when I pass the horizontal line, it does cut it at 2 locations. It fails to be a one-to-one function. So this one is not a function. This one is a function, but not one-to-one. All right, very good. Now let's go see a couple of things. Now I'm going to talk about inverse functions. F of x is a one-to-one function. Let's take a one-to-one function, and it has ordered pairs x and y. F inverse of x, this is how you read it, F inverse of x. It doesn't mean f to the, so this one is not f of x to the -1. So make sure you understand that thing, and you also don't put it like that. Okay, don't do any of that. Not that, not that. It is f inverse of x. All right. So that f inverse of f of x is x, and f of f inverse of x is x. So I'm doing composition. What does that all mean? Now let's think about it. I have a bubble. I start with x, and I go and I do f of x to it. So I start with x, I end up with f of x. What f inverse does, it takes this and applies f inverse to it. This one is f going away. This one is f inverse coming back. And guess where he ends up? At x. So if it was not one-to-one, remember you could not do that. You would go someplace and then maybe end up at a different place, right? That's why you want to have a one-to-one function. Okay? So you go away, and then you come back to where you are. F inverse of f of x is x. How about the other way around? You take the inverse first. Let's go take f inverse. So this is f inverse of x. And when you do f to it, you're going to end up in x as well. So both ways apply. Okay. All right. Now, what does this look like? Remember, you went from x to y, y to x. In other words, when you f a function and you end up calculating a point, and that point is 1, 2, and the inverse of that function, let's say this is 1 and f of 1, the inverse of that would be the reverse of that. In other words, 2, 1, 2, 1. Okay? So when you do this with enough points, you'll see a pattern. You'll see that whenever you have a function, its inverse will be mirror image along y equals x, because you are reversing x and y. So this one is 2, 1. It was 1, 2, now it became 2, 1. So in other words, if I have some like this, let's say starting at 3 and going up, what will be the equivalent? So if this is my f, your f inverse is going to look like this. It's going to start with 3, and it's going to go like that. So if you see, you put a mirror in here, you're going to see this piece. It's mirror imaged. And another thing which is important, let's say you have an asymptote that comes up here like that. How will this one going to reflect along the y equals x? What will happen to it is this horizontal asymptote is going to become a vertical asymptote. Do you see that? All right, so these are all good information. Let's go also, where we're going with this is that because logarithms and exponents are inverse functions of each other. So let's look at how we find inverses of functions. There are 4 steps. Just follow the steps and you'll be all good. Replace f of x with y, interchange x and y, solve equation for y, replace y with the inverse notation. What does that mean? So let's do these steps. The question is find inverse of f of x equals 2x plus 1. Replace f of x with y. All right, so let's go do that. Y equals 2x plus 1. Instead of f of x, I just put y. Interchange x and y. Okay, so instead of y, I put x. Instead of x, I put y. Now you're going to go solve for y. Pull that out. Look what you're going to do. You can subtract 1, and you'll get x minus 1, and then you have to divide by 2. Here we go. When you write it nicely, this is how it looks like. X over 2 minus 1 over 2. What was the last step? Replace the y with the inverse notation. Here's the inverse notation. And guess what? F inverse of x is actually the inverse of that. So let's look at one more thing. Let's go plot these two and actually see if they're mirror image along y equals x. So I'm going to start with 2x plus 1. I'm going to do that in black. So my y-intercept is 1, and the slope is 2. 1, 2 over 1. And I'm going to draw that. So this is 2 to 1 slope. Okay, let me go put that y equals x. There's a little swing in there. But let's look at, this is my f of x. Let's go do f inverse of x. I'm going to do that with orange. F inverse has a y-intercept of negative 1/2. Here's negative 1/2. And its slope is 1/2. So I'm going to go to 1/2. So that means I'm going to go 1, and then I'm going to go 2. Here it is. When I draw these two things, watch what it's going to look like. Do you see it? I mean, I kind of, I should have used the ruler. But look at it. Here's my original. Here's my inverse. And they are mirror imaged along y equals x. So you can always go and check it graphically what's going on. And the inverses will always behave that way.